Hello class, we're going to look at 1.4 properties of real numbers today. The main thing we're going to focus on in this section is the distributive property. While we're working with the distributive property, we're going to be using these other properties: identity, inverse property, commutative, associative property, but I'm not going to stop and address them individually by showing them. So we're going to focus on the distributive property, and we're going to focus on like terms. In 1.4 of your textbook, it will give you an example of each of these and discuss them. But we're just going to focus on the distributive property. Okay, so let's look at that distributive property here in our first part. Remember, at any time, you are welcome to pause me and write down your notes and then hit play and listen to what I have to say. Otherwise, I'm going to keep going, so you're going to probably have to pause at some point in time if you're trying to keep up. For any real numbers, a, b, and c, the following are true. So this is our distributive property. What it's saying is that if we have a number in front of the parentheses being multiplied, so it's pushed right next to the parentheses, then we're going to go ahead and distribute it into our parentheses. Now when we distribute it, this is going to be multiplied by each of the terms on the inside. So notice that it becomes a times b, the plus sign's already there, a times c. An uncommon way of seeing the distributive property, but you will run into it, is when we have our variable or our number attached to the back of the parentheses. Same concept going on. It's pushed right next to the parentheses symbol. That means multiplication. So we go ahead and distribute into the parentheses. We end up with a times b or b times a times c or c times a. So remember, the order here is not going to make a difference. 2 times 3 is the same as 3 times 2. Yep. When working with the distributive property, it doesn't just apply to 2 terms inside. It can also be 3 or 4. Same idea. We're going to distribute this into the number of terms that are on the inside of our parentheses. So this one happens to have 3, so we end up with 3 results back here. So let's look at a couple actual examples of these. So what we have here is we have 2 being multiplied by our parentheses. We learned order of operations says it'll work inside parentheses first. Well, m plus b, those aren't like terms. We can't actually add those. So then I move to the outside where we do have the multiplication. We're going to take this 2 and multiply it into each term. So I have 2 times m plus 2 times p. So we've taken the 2 and distributed it into the parentheses. Now we can go ahead and actually multiply these to give us 2m plus 2p. So these are, again, not like terms because we have an m and a p, so we can't go any further. We've just distributed the 2 inside. Okay. On the second example, we have a negative sign in front of a parentheses. What that means is we really have a negative 1 in front of our parentheses. We're going to distribute it. So that gives me negative 1 times 3m and a negative 1 times a negative n. Okay. If we go ahead and multiply these, a negative times a positive is going to give me a negative, and we have 3m. Negative times negative is a positive. Remember, we don't have to write the 1 in front of n. It's assumed to be there, so I can just write that as n. Again, those aren't like terms, so that you can go ahead and stop there. Okay, so let's do a little refresher on like terms. Okay, so like terms are terms with exactly the same. See if you remember. variables raised to exactly the same power. So our definition of like terms is terms with the same variable, same power. So here's an example of like variables. 3x squared and negative 7x squared. Exact same variable, same power. So these are like terms. See if you can write down two that would not be considered like terms. I'm going to go ahead and try to guess to see what you came up with. Maybe you came up with 3 and 4x. Probably not the ones you picked, but hopefully what you picked were two that didn't have the same variable and don't have the same exponent. So notice the 3 doesn't have the x, so those would be considered not like terms. Alright, so let's look at combining like terms or simplifying. So the idea is to look for the terms that have the same variable with the same exponent. I notice that the first term is a negative 12y. Second term is a positive 4y. Third term is a 3, doesn't have a y, so that's not included. And the third term is a positive 2y. So these three are considered like terms. So I'm going to go ahead and combine these first while they're opposite signs, so I find the difference. The 12 is further away, so it's negative. Remember when we add or subtract like terms, we keep that variable. I still have the plus 2y and the plus 3. So notice how they're just moving their way through. Now we can combine these. Well, negative 8y and a positive 2y, again opposite signs. Keep the sign of the one that is further from 0. And we have the plus 3 and back. Now negative 6y and plus 3, not like terms. So that's as far as we can go with that one. Okay, so let's go back to the distributive property, but we're going to include like terms now. So after we distribute, there's going to be some stuff to work a little more with. So let's start with number 33. Notice that we actually have the distributive property happening twice in this problem. The first one is this negative 2 that's in front of my parentheses. So I'm going to take that and only distribute it into the parentheses it's attached to. So I end up with negative 2 times m, negative 2 times a positive 1. And you may start skipping this step as you start to get more comfortable with the distributive property. In my second one, I have a negative 1 here, and I'm going to distribute that into my second parentheses only. So negative 1 times m, and negative 1 times negative 4. Okay. So you can see that we only distribute the negative 2 in the first parentheses, only distribute the negative 1 into the second parentheses. Let's multiply these out. So negative 2 and m gives me negative 2m. Negative 2 times 1 is negative 2. Negative 1 times n is negative m. Negative times a negative is a positive, and we have a 4. Now we're going to find like terms. I have a negative 2m, and I want to see if there's any other like terms with just an m. Well, I notice I have a negative m in my second term. Again, remember that this is a negative 1m. So those are the same sign. I'm going to add them, keep the sign, and we keep the m. I also have a negative 2 and a positive 4. Well, negative 2 and positive 4 are opposite sign, so we find the difference, and it's a positive because the 4 is further from 0. These are not like terms, so I'm done. Notice that I'm writing this in descending order. I'm starting with the variable to the highest power, which happens to be 1, working my way down. So I've got one with a few more steps going on. So number 39. So if you want, you can go ahead and pause and then start the problem. When you come back, we'll finish it up. Welcome back if you paused me. If not, let's move on. Here's the trap. So 2 plus 3 times 2z minus 5. Well, that 2 plus 3 looks really friendly, like we could just add that real quick, it'd be 5, and then move on. But remember, our order of operations says that we have to do multiplication before we do addition. So we need to take this positive 3, distribute it in first, and that 2 out front is just going to continue on down. In my second parentheses, I have a negative 3 in front, so I'm going to distribute that in. Notice I'm not going to distribute it to the negative 8 because that's behind. And this is a minus 8. Notice that it's not right next to the parentheses. So the 2 comes down. Then we have positive 3 times 2z and a positive 3 times negative 5. Now let's worry about the negative 3. So we distribute the negative 3 times 4z and the negative 3 times 6. And again, the minus 8 is just going to tag along. So we've distributed. Now we go ahead and multiply everything. So the 2 is not being multiplied by anything, so we bring that down. 3 times 2z is a 6z. 3 times negative 5 is negative 15. Negative 3 times 4z is a negative 12z. Negative 3 times 6 is negative 18, and then the minus 8. And now we'll combine like terms. What I like to do is identify the variables first and pick the one with the highest power so that I can start that process of doing descending right off the bat. So 6z and a minus 12z. Those are like terms. Check to see if anything else has a z. It doesn't, so I go ahead and combine those. They're opposite signs, so I find the difference, and the 12 is bigger. Okay. The 2, the negative 15, the negative 18, and the negative 8 are all like terms. So I'm going to go ahead and combine these two first. Well, opposite signs, so we find the difference. Keep the sign, and I'm just going to write them minus 18 and minus 8. And now I'm going to do the next two. So the 6z is done, or the negative 6z. So that's just coming along for the ride. And we just keep working with these. So I'm going to combine these two now. Same sign. So I add them. Keep the sign. And we have the minus 8. Again, same sign. Add them. Keep the sign. And the negative 6z is coming along. See, so notice that I did that first. It was done. And I just kept bringing it along until we got to our final answer. Go ahead and try one more example. And this example deals with some decimals. So we're going to end up seeing decimals in front. We're going to see fractions in front. Same concept. We're going to distribute them in. So it doesn't change just because this is a decimal. So I have 0.25 times 8 and plus 0.25 times 4p that's P. We're going to take the negative 0.5, distribute that in. So I have negative 0.5 times the 6 and negative 0.5 times the 2p. So now we're multiplying some decimals. What I noticed as I was doing this was 0.25 is the same as a quarter or 1/4. Well, and I noticed that a 4 will reduce with both of these nicely. So I'm just going to convert that 0.25 into the fraction. If you're using a calculator, it might be easier just for you to leave it in the decimal form. On my second grouping, I noticed that 0.5 is just a half, and it reduces with both of these nicely. So I'm going to change that into a 1/2 and a half, leaving me with the 6 and the 2p. Not necessary, but if it helps you multiply just see fractions instead of decimals, you can do that, or you can just multiply the decimals. So I'm going to make all of these fractions by putting them over 1, and then we can start the reducing process. So 4 and 8 reduce. So this is 1 times 2, 1 times 1. So that just gives me a 2 plus reduce. And 1 times p, 1 times 1. So this is just p. Reduce again. This time I have negative 1 times 3, so negative 3. Reduce. Negative 1 times p is a negative p. Again, find like terms. Well, 1p minus 1p is 0p, or they're gone. 2 minus 3, find the difference, keep the sign of the one that is further from 0. So that's working through the distributive property, combining like terms. As you went through the video, remember you can always pause, rewind, go back, check examples, stuff like that. I hope it was helpful, and have a good weekend.